Good morning, students. Today we are going to learn about a real number. It is the chapter 1 in class 10. And under this chapter, today we are going to learn about an introduction, Euclids division lemma, Euclids division algorithm. And three more section is also there that we will see in the following days. Today we are going to see the introduction and Euclids division lemma and Euclids division algorithm. Here we go to an introduction. The world of real number. The world of real numbers we already explored in the class 9. So just we can have a brief recall of the real numbers. And this figure shows a brief recall of the real numbers. The real number is nothing but a collection of rational numbers and irrational number. Real number is a collection of these rational numbers and irrational numbers. So you can see the rational number have some collections. That is the collections of integers, whole numbers and natural numbers. So rational number have collection of these three numbers and real number have collection of all these things. So every natural number we can call it as real numbers. So every whole number is a real number, every integer is a real number, every rational number is a real number, every irrational number is a real number. Now we will see what are these numbers. First, natural number. What is natural number? Natural number is just a counting numbers. Just like a 1, 2, 3, 4, 5, it goes on. Next, the whole number. What is the whole number? It's just a natural number including 0. Just I have written a keywords. We don't need to go for deep here because we know it. So just with the keyword we can recall. So whole number is a natural number including zeros. 0, 1, 2, 3, 4 and so on. And next is a integer. Integer is a whole number including negative numbers. Minus 3, minus 2, minus 1, 0, 1, 2, 3 and goes on. The negative side also it goes on. Right? Next is a rational number. Rational number is in the form of p by q and q is not equal to 0. This p by q is it's like a fraction and the denominator is strictly not equal to 0. So any number in the form of the fraction that is a p by q and denominator is not 0 is a rational number. So that exists like in a fraction, then there should be a decimal, right? So every fraction we can convert like in a decimal. The decimal expansion is either terminating or non-terminating reoccurring. So if you express this p by q form in the decimal expansion, it should be a terminating or non-terminating reoccurring. So example for the fraction 2 by 3, 5 by 1, these things. And for the decimal 3.1, the decimal is a terminating. 5.6 decimal is terminating, and 3.141414 it is not terminating but reoccurring. 14141414 it goes on. So these kinds of numbers are rational number. Next is a irrational number, just an opposite to the rational number. It cannot be in the form of p by q. Number which can't be right in the form of p by q is a irrational number. So in terms of decimal expansion, non-terminating, non-reoccurring. So it will not terminate and it will not reoccur. It will be different. The decimal places will be like different. It will never repeat. Never repeat. That's what it's saying in this. So example, the pi is equal to 3.14 and goes on. Square root of 2, 1.414 and it goes on. These are the examples for irrational numbers. So next, before going to an Euclid division lemma, we can revisit a normal division. So normal division which we done like an example, I will give one example like an 10 divided by 5. How we will divide the 10 divided by 5? We will do normal division. 5 2s are 10 and remainder 0. Right? Here we will get one relation. So what relation? The dividend, the 10. The 10 can be written in the form of divisor into quotient plus remainder, right? Divisor is 5. 5 into quotient is 2. 5 into 2 plus remainder. Here the remainder is 0. So see the 5 2s are 10. 10 plus 0 is 10. So 10 is equal to 10 plus 10. We will get this relations, right? And another example I will give. Maybe 10 divided by 4. So what happened? 10 if you divide by 4, 2 times 8 and the remainder is 2, right? So 10 here it is expressed as a divisor into quotient, 4 into 2 plus the remainder is 2, right? can check. 4 2s are 8. 8 plus 2 is 10. So we have this relation with the normal division that we have learnt already, and we used this relation, right? And this relation and Euclid's division lemma have close relationship. Yes, this and that relation are almost same. We will go for the Euclid division lemma and we'll come again to this example. Just we can link that. Here. Euclid division lemma. So Euclid division lemma says that given positive integer a and b, there exists a unique integers q and r satisfying the following: a is equal to bq plus r, the 0 less than or equal to r less than b. So here it clearly sees that the lemma says given positive integer. So we are dealing only with the positive integer. When we say the Euclid division lemma, it involves only the positive integers a and b. Then there exists an unique integer q and r, the following and satisfying the following relationship. This relationship is almost like what we saw in the example, right? See here. A is a dividend is equal to b4. B is here we consider as a divisor into quotient plus remainder. The same. The A is a dividend, B is a divisor, 2 is a quotient plus remainder. Yes. Now you understand, right? Euclid division lemma and the normal divisions also have a close relationship. Almost it's the same. And here this one more condition is given: 0 less than is equal to or less than b. Yes, the remainder is less than b. It can be 0 also. So we have seen the example with the remainder 0, right? So this example shows with the remainder 0, and this example shows remainder with an integer, but you can see the remainder is less than the divisor. The remainder is less than the divisor. Always it will be strictly less than divisor. That's what the Euclid's division lemma says. Now what is meant by lemma? Lemma is just a proven statement which is used to prove another statement. So it's a statement is already proved. We can use this statement to prove other statements, right? Okay, we go for the next content. Next content is a Euclid's division algorithm. What is algorithm? Algorithm is a process or set of rules or a procedure for solving a problem. So any process or any rule or any procedure that you use it to solve a problem is called as an algorithm. Mostly we will use in the mathematics and computer science. So here we use a Euclidean division algorithm. Here we go to the content. So Euclid division algorithm is used to find, see here to obtain a HCF of a comma b with a greater than b and a and b are two positive integer. Follows the steps below. To obtain the HCF, the following steps are involved. That's an algorithm for the obtaining HCF, and it's a certain condition is given. It should be a greater than b, and a and b are two positive integer. A and b are two positive integers. Previously we saw the lemma also contains involves only the positive integer. You can see here is also a positive integer. So we are dealing only with the positive integer here, right? So we know to find the value of HCF with the prime factorization method, right? Here we are going to learn the division algorithm. So Euclid division algorithm may be simply called as a division algorithm. The same way Euclid's division lemma also called as division lemma. Simply we can call it like that. People are calling like that, so we can also call that. So now the algorithms are here. The three steps are there to find a HCF. Step 1, apply Euclid division lemma. Euclid's division lemma, we find q and r such that a is equal to bq plus r. So any two numbers, just now we saw an example. If it is any two number is given, so any two number is given, we can express in the form of a is equal to b into q plus r, right? So if here they say we are going to find an HCF of a and b, so the a and b should first step we have to express in the form of division lemma, and you can see this condition also will be satisfying: 0 less than or equal to or less than b, right? The next step, if r is equal to 0, if you get a remainder r is equal to 0, then b is the HCF of a comma b. Then what is a divisor there? That is the HCF of a comma b. If r is not equal to 0, If r is not equal to 0 there, then apply a division lemma to b and r. So if it is r is not equal to 0, again we want to apply a division lemma to b and r, where b is a divisor here, r is a remainder. So the next step, we are applying a division lemma to divisor and remainder. Right? Divisor and remainder. Here also you want to check which is the greater. A is greater or b is greater. That a is you took as a dividend. The same. Here also you will check whether b is greater or r is greater. And it always says b is greater than r. So b is a divisor, dividend. Sorry, b is a dividend and r is a divisor. So again we want to, the step 3 says that continues the process till the remainder is 0. So we want to continue the above step till we will get a remainder 0. So some stage, at least some stage we will get a remainder 0 for the positive integer, right? I am talking about the positive integer. While doing this process, some stage we will get a remainder 0. Maybe the second stage, third stage, fourth stage, can be, it depends on the questions, right? So some stage you will get a remainder 0. The divisor at the stage, what is the divisor? That will be a required HCF. The divisor at this stage will be the required HCF. Which stage? When r is equal to 0. When r is equal to 0. That stage. We want to continue the division lemma. If it is r is not equal to 0, we want to consider the divisor and the remainder. Again, apply the division lemma. Again, if it is remainder is not equal to 0, again consider that step, divisor and remainder. I think you will understand by some problem. Then next we will go to a problem. So here is the problem 1, and in NCERT book the first exercise, it's our first problem. Using a Euclids division algorithm to find the HCF of 135 and 225. It's clearly said use Euclids division algorithm. Use Euclids division algorithm. So you are strictly asked to use a Euclids division algorithm. You can't do this sum with a normal prime factorization method to find a HCF, because it is asking use the Euclids division algorithm. So strictly you have to use it, right? The solution. To use the division algorithm, you should remember the step 1, 2, 3. The step 1, we have to apply the divisional Euclids division lemma. If r is equal to 0, then divisor is the HCF. If it is not, we have to continue until we will get a r is equal to 0. So first thing we have to say which one is greater. We have to see which one is greater, 135 or 225. 225 is the greater. So we apply a division lemma to 225 and 135 to get. So 225 is equal to 135 into 1 plus 90. We will get this expression. Just doing by a normal division. You can apply this division. See, the 225 is divided by 135. So 1 times 135 and remainder is 90. Right? 90 we get. So next. Here the remainder is not equal to 0, right? So in the algorithm says if the remainder is not equal to 0, we have to repeat it with the divisor and the remainder. Yes, since the remainder 90 is not equal to 0, we are applying division lemma to 135 and 90. 135 is a divisor in the previous stage and 90 is a remainder in the previous stage. So we considering that, and 135 is the greater and 90 is the lesser as the condition it's given. So A is greater than B, then A is a dividend and B is a divisor. Here the 135 is a dividend and 90 is considered as a divisor, and you will get divided by 1 and the remainder is 40. We will get this expression. Yes, 135 is equal to 90 into 1 plus 45. That is 90 into divisor into quotient, 90 into 1 plus the remainder. Right? Again, you can see here the remainder, the R is not equal to 0. So what we have to do? Guess what we have to do? Yes, we have to redo. We have to again apply the division lemma to the divisor and the remainder. Right? So we consider the new divisor 90 and the new remainder 45 and apply the division lemma to get. So applying division lemma to the both 90 and 45. In this stage we will get, right? You can see the 45 is a multiples of 45 is 90. Yes, so we'll check. So 90 divided by 45 will get 2 times 0. Here the remainder is 0, right? So what the algorithm said, can you guess? If the R is 0, we can stop there And what will be the HCF? Can you remember from the division algorithm? Yes, divisor at the stage should be the HCF. Let's see. We observe that the remainder at this stage is 0. Yes, we observe that the remainder at this stage is 0 since the divisor at the stage is 45 and the divisor is the 45. So what is 45 now? The 45 is the HCF. So HCF of 135, 225 is equal to 45. Right? Once again we have a recap of this. So we have to find the HCF of the given number 135 and 225 using a Euclids division algorithm. So first we are seeing which is the greater, 225 is the greater. When applying a lemma just by division we will get this expression. 225 is equal to 135 into 1 plus 90 and remainder is not equal to 0. So we are considering for the divisor 135 and 90. Applying for the division lemma we will get a, if we divide a 135 by 90 we will get this expression. 135 is equal to 90 into 1 plus 45. Again the remainder is not equal to 0. We can again considering the divisor and remainder. Here the divisor and remainder is 90 and 40. At this stage we get a 0. Just for in the normal division you can use this division. If you are well versed without this division also you can write the expression. If you have doubt you can do this division in the rough column and you can write. That's not a problem. If you write or not write, it's not a problem. But this expression is matter. Right? So in this stage we get a 0. So which stage we get a 0? That divisor is a HCF. So in this stage we get a 45. So HCF of the given number 135 and 225 is equal to 45. Right? So here we go for a next example. It's a problem 2. It's a third problem in the first exercise 1.1. An army contingent of 616 members is marched behind an army band of 32 members in a parade. So it's two groups. The first group is an army contingent, contains 616 members, and another group is an army band group of 32 members in a parade. The two groups are to march in the same number of columns. So they have to march in the same number of columns. What is the maximum number of columns in which they can march? So this is a word problem. There's a hint whether you want to find an HCF or LCM. Right? What is the hint? Can you say that? Yes, the maximum number of columns. So it is given the word, the hint word. You already remember many hint word to find HCF and LCM, right? So here is the maximum number of column is the HCF. Given the maximum number of columns, that means we have to find a HCF of 616 and 32. So if you found an HCF of 616 and 32, that's the maximum number of column that the army have to do the parade. So in order to find the HCF, let us apply a Euclids division lemma. Right? So if you continuously apply this Euclid division lemma, you will division algorithm, you will get practice and it will be easy. It's a first you are learning, right? So you have to practice it again and again by applying many problems, right? So here the 616 and 32 you can guess now, right? So 616 is a greater than 32, so this is a dividend and this will become a divisor. Yes, 616 divided by 32 will get 19 times and remainder is a 8. So this we can express in the form 616 is equal to 32 into the quotient is 19 plus 8, right? So in this stage the remainder is 0? No, it's not a 0. So we have to apply division lemma for the 32 and 8, right? So we are considering a new divisor 32 and the new remainder 8. Apply Euclid division lemma. Yes, the Euclid division algorithm says that we have to continue until we get r is equal to 0, that is remainder is equal to 0. In this stage remainder is not 0, that's why applying a Euclid division lemma to this divisor and the remainder, right? So now it will get, because you can see the 32 and 8, the multiples of 8 is 32. Yes, 32 you can write 8 into 4 plus 0, 8 4s are 32 plus 0. So in this stage we get a remainder 0, right? So in this stage we get a remainder 0. Then which is the HCF? Guess? Yes, the divisor 8. Divisor 8 is a HCF. So HCF is equal to 616 and 30. HCF of 616 and 32 is 8. So the question asks the question is about what is the maximum number of column which they can march. So what is the maximum number of column they can march? Is we can 8, right? So they can march in the 8 columns each, right? Thank you.